All right, we're going to go ahead and get started. Hello, everyone. My name is Jonathan LeBlanc, and I run the Developer Evangelism Program for North America at PayPal. Now, a lot of my background is in open web standards, which is a lot of what we're going to be talking about today. I've probably worked at PayPal for about a year and a half now, and when I first started at the company, the first thing they asked me was, what do you think of our APIs? This was old SOAP-based stuff. And I was very critical. I said, your stuff is hard to implement. It's incredibly complex. It's not really leveraging off of open web standards. A lot of the standards that are used nowadays, a lot of the standards that I've built and worked on for years within open specifications such as OAuth, within the social realm, through Open Social and such. And it took us probably about a year and a half to rebuild the entire architecture based on all of these standards. And I'm not going to talk about PayPal, I'm not going to talk about the implementation, but I'm going to talk about these open web standards and everything that we've gone through from the companies I've worked at in the past on implementing something like this within the JavaScript layer. Because server-side implementations are very standard out there for systems like OAuth and API consumption, but they get complicated when you start integrating them in the JavaScript layer, when you start working with them in a client-side integration. And that's where they get fun. That's where they get interesting because you can do a lot of cool things with these same open standards. And they work really well nowadays. When I started working with them about 6 years ago, back in the basic auth days when we were still passing passwords, username and password through to auth ourselves, it was complicated to work with this. And there were so many hacks that we had to work with in order to get standards like this to work. So we're going to work on actually implementing them the correct way and looking at these standards within the RESTful construct. But really what we're going to be covering are a couple of key factors here. So, of course, when we're talking about RESTful web services and working with them in a secure way, we're going to touch on key RESTful architecture steps that we're going to need to implement in order to work with these APIs. Some of the key values that a lot of companies out there don't really implement, don't really work with. You know how many times I've been to conferences and talked to companies who have said, oh yes, I have a RESTful API. And we have a RESTful API because we support GET and POST. I'm sure a lot of you have heard this in the past as well. But no, you support some basic HTTP standards, not the entire verbiage there either. And that becomes a problem because there's a complication in the industry around what an actual RESTful web standard is and what you should be doing with it. Some of the basic principles that are implemented by a lot of companies out there in a lot of different APIs. And once we take a look at those RESTful API standards, we're going to dive a little bit deeper. We're going to take a look at some of the hypermedia constraints within the RESTful specification that make for really nice automation techniques, really nice ways of building out your entire program architecture in order to automate the way that you do things, to reduce your code base, to increase the performance, and to do so in a very standards efficient way. So once we deal with those particular topics, we'll go in and we'll take a look at the auth system. Working with authentication, the act of logging a person in, as well as the act of authorizing or granting an application permission to do something on your behalf or to access your details. There's a complete separation in that, and unfortunately within OAuth 2, when the spec first came out and was starting to be implemented, and Facebook was actually one of the first largest implementers out there, it got a little confused. So the act of authentication and authorization kind of got commingled. And it became problematic in the industry, and it took us a while to finally get standards that support both. But at the end of the day, all we're really talking about is consumption of APIs. When you have a developer resource that you want to allow people to interact with, these are the standards that you're going to be working with in order to make their lives easier, to allow them to automate their implementations, ways that you can implement it to make their lives easier. And at the end of the day, that's all you care about. That's all that I care about. I hate working with APIs that are incredibly complex for no apparent reason. And thankfully, OAuth 2 as a standard, REST as a standard, have made things truly easy for us. All right, so before we dive really far down the rabbit hole here, Let's start by talking about some of the JavaScript challenges that you're going to run into. These are things I'm sure, as JavaScript professionals, a lot of you have encountered in the past. These are things that I've had trouble with over the years working with these standards until there were these standards in place to really make this work. Back when I was working at Yahoo, we actually built out the first JavaScript SDK that they made available on top of their social platforms. And we did so back in the OAuth 1 days and the OpenID days, back when things were complicated to implement. And we found some really hacky workarounds to get this working. So we'll take a look at some of those as well. So the first thing that you're going to have to deal with is a lot of the same origin policy issues. The cross-origin resource sharing, everything that you're going to be doing in order to interact with a lot of different APIs out there. This is a standard. You're working with an external API, you're working with an external API endpoint, you're going to get into problems with the same origin policy, where the browsers are going to block your the subdomain or external domain access for you. But it can be problematic at times because you're working with this, and there are some workarounds to that. A lot of what has been done in the past to mitigate this concern with a lot of the JavaScript SDKs out there are things like building in a proxy layer. You have a server-side proxy script that you call to. Kind of defeats the purpose of having a client-side implementation, if you ask me. Then you have things like Flash proxies. YUI used to do that in their library for the longest time, and where you can actually communicate through the Flash layer. You can also do so through standards like JSON-P. So making a request to an externalized domain and wrapping it in a callback, essentially what you're doing is injecting a script include into your page that allows you to kind of hack around the entire same origin policy. So you're going to make a request to this externalized resource, return back, and a callback will be immediately executed. And within that callback is your resource, basically what you're calling out to and what you want to accept in. So JSON-P has some good points. It has some bad points. Definitely, it introduces some security concerns, but it is a good standard out there. It's a good workaround, and one that's used as quite frequently today. Another one is CORS, or cross-origin resource sharing. This is one that is not as widely known, but is an option in the standard. Essentially, the way that it's going to work is that you're going to send the externalized resource an origin header with your request. And what they're going to do is send you back this access control allow origin with the same site. Essentially, what this is doing is giving you an exception on that site to be able to make the request back and forth. It's a permissioning issue, as you would. But not really overly implemented, not the best way of implementing. But these are two options that are available to us. These are two options that we can work with. There are a lot of other options out there as well. But these are two standards that are fairly good. All right, then the biggest problem that you're going to run into in a client-side level is keeping things secure. All right, so what you're basically going to be working with is some sort of tokenized system. If you're working with an auth level, if you're working with OAuth, if you're working with basic auth, if you're working with any auth, you're going to have something that you're going to need to keep secure in order to securely identify. Think of it like a password. So if you're using basic auth, you want to hide your password. If you want to use OAuth, you want to hide your secret. These are ways of uniquely identifying you and should be kept secure. But exposing them in the JavaScript layer does the complete opposite of that. So these are things that you have to be concerned about when working with standard OAuth implementations. So when we talk about OAuth, when we go down that level, all the standard implementations out there, they are based on server-side implementations. And it makes sense because you can hit almost every server-side language out there based on one particular standard that you implement. But when you start dealing with the client side, when you start dealing with the JavaScript layer, things get a little bit more complex and fun. And we have to work around the standards. The other issue is that one of the biggest problems with with essentially building out your API infrastructure to request API data or to utilize API data is as you're wrapping it in the client-side implementation, once you have this way of consuming that data, the problem is that you're mapping out your entire program architecture. You're essentially saying, every piece of data that's coming through, this is the direct action on it. And even though it might not be a true big concern, it is a security issue because you're essentially saying, this is how my site works. I have data coming down, and once this data comes down, this is how I change the site based on it. It opens you up to a whole new slew of security issues on the JavaScript layer. So there's things within the RESTful standard that we can use to mitigate this concern. There are these open standards that are available that not a lot of companies do implement. And one of the actual reasons why I really enjoy working on the developer products at PayPal is because they did implement it. They worked on it. They had people that were contributing back to the industry and trying to move the specifications forward. All right, so that's some of the issues that we're going to run into when it comes to the JavaScript concerns. So let's jump into the RESTful specification, working with REST, and working with the API data models and automation, building in automation utilizing those RESTful standards, the things that we're going to need to be concerned about when we're really working with the standards. So first off, let's take a look at some of the core concepts. Now, I am not a REST pragmatist. I believe that the specification is put in there for best guiding practices, and they should be supported as long as it fits company methodologies. It's one opinion that's out there. There are many. I don't believe in building in an architecture based on an open source implementation simply because it's there. If it makes sense, it should be implemented. If it adds something, it should be implemented. And there are a lot of good things in REST that should be implemented, basically almost everything. But within the vast majority of the RESTful API implementations out there with companies that consider themselves RESTful, they implement a number of different things. They implement a number of different standards. So when you hear those companies that are saying, we're RESTful because we support the HTTP request verbiage, they are partially right. Part of the RESTful specification is supporting that verbiage, get, put, post, delete, supporting those verbs as standards. But the problem is that a lot of the companies out there, a lot of the API implementations utilize these standards as just a mechanism for sending in a payload. So I've actually seen some APIs, some implementers out there that say, okay, send a GET request with these query string parameters through, or send a POST request with this POST body through, to perform this action. But you can interchange them. You can interchange GET and POST, and they have the same effect. But that's not how it should be. These HTTP request verbs should be action-oriented. You have GET for reading. You have deleting for removing. Put and post for modifications of data or setting new data. They have actions in and of themselves, and they should be treated that way. They should be treated as if you're performing an action based on the verbiage that you're using. And that's how it should be. Then, using proper HTTP status codes. This is another complaint I had around the old PayPal APIs was, how many of you have worked with them in the past? The classic APIs. Okay. So you'll be familiar with the vast majority of response error codes that you can get, right? And the cryptic error messaging. And I had a problem with that because it's not to standard and because I don't want to implement a whole error specification and handling mechanism for just one API. So building to proper HTTP status code standards is what we implemented in the new RESTful API as well. What a lot of implementations within API architecture do. So specifying standard responses for errors actually helps with automation. As you're building in your program architecture, you have to have a way of handling error cases and performing actions and modifying your site, your application, based on those error stances. And that's the whole point. Then, no version numbering in the URIs. Now, we're not the best. We're not the best with this one. This one is a choice that the company made overall. Well, you had two camps over at PayPal. They were saying no version numbering or version numbering to support the old way that we do things in our classic APIs. But one of the standards within REST is don't utilize version numbering because it implies a state. It doesn't future-proof. You can't modify the code base and then change the version number because that either breaks old implementations or you have to support them. The reason behind this is because, working on different APIs, you'll be familiar with this happening where you increment a version number or change something and all of a sudden it all breaks because they no longer support the old version. And you didn't get the email. But the version numbering, we chose to go against that to support our old versions, or basically our classic APIs. And we did so because we're only going to be incrementing every several years. You're going to be building modifications under existing version numbering for quite a long time, but only when there's a massive implementation change are version numbers going to be incremented. And we've already said that we would support older version numberings. So if you're willing to support it, you could utilize it. But I really hate when APIs decide to increment version number and break everything. I don't know how many times that's happened to me in the past, just over and over again. And I'm sure a lot of you have gone through the same thing. Then, as we're going a little bit further down, specifying a return format via the HTTP accept header. And so essentially defining the data that you want back, the data format that you want back for your payload within a header. So application JSON, for instance, in your accept header. I've seen a lot of different APIs do this different ways. So supporting that mechanism can be different depending on the API that specifies it. I've seen people do this as specifying .json or .xml at the end of the URI that they're making requests to. I've seen them integrate this into a post body. But there's multiple different ways, but essentially following the principles. They're not being to specifications, but they made this choice as a company. So following the principles as a guiding factor is very important within REST, but it shouldn't be the be-all, end-all. And then, my favorite, the double rainbow effect of HATEOAS. I love this concept because this essentially takes everything that you're doing. You don't have to map out every single request that is in an API. Implementing this standard, which we'll take a look at in just a minute, will allow you to build incredible automation into your system. That it'll allow you to streamline your code base to basically your application has no knowledge of the next state that it's going to hit. It knows the first entry endpoint, and that's it. And then it can take a number of actions based on that. And the reason this is good, the reason this is proper, is because if you map out your entire API infrastructure in your application, then you're not future-proofing anything. You're going to have to support that code base. You're going to have to modify it as the API provider makes the modifications. So utilizing this, you only have one entry point, and then your application builds around it. Then one of the other aspects within REST that's really kind of cool is kind of a uniform interface subconstraint. Essentially, it's a way of defining how data is supposed to be provided back and forth in a way that's easy for developers. So when we're talking about this, there's some core principles behind REST which are actually quite good. So first off is the resource identification. Every implementation, every API infrastructure has to have the resource identification. Essentially what this means is the owner of the API themselves that are making the request through should be the same one that's modifying the end result. So essentially you're not an API provider that implements some other resource out there that you don't know. So the resource identification is an important aspect, and it makes sense because essentially the reason behind this is because the person that should be modifying the API is the data provider themselves, because they'll know the most about it. Then resources, which are kind of like concepts. Think of it like pay credit card or pay by credit card. That's a resource. So those must be manipulated via representations or strict data principles, anything that's modified in bytes. So with the resource identification, what you're really looking at here is you have concepts behind APIs like pay by credit card, pay by PayPal, refund payment, and you send in a resource payload for how to modify that. So basically, all the data that's going to be needed by the API itself to make those modifications. So the actual hard data. Self-descriptive messaging. Essentially, what this means is that when you make an API request using REST, you should have all the information supplied in that request that's needed in order to make the request. So think of it like status code plus payload plus all of that information. Basically everything that you need in order to make the request right away. And then finally, the other constraint is this hypermedia as the engine of application state. It has a really awesome title. When I first started working with this, I looked up, how do you pronounce this in an acronym form? You know how many different pronunciations there are out there? I have not seen one that has overlapped, so I'm calling it HATEOAS. I've done it for quite a long while. And really the way that you should be thinking about this is a hypermedia constraint. You're putting a constraint on your data. Because HTTP requests are essentially wide open, you have to have these constraints in order to define specific actions that can be made. And the way to think about this particular constraint, the HATEOAS constraint, is in how we consume APIs. It's actually a really easy concept. So this is how we actually consume APIs the vast majority of the time. We have a mapping of every API endpoint. If you're accessing PayPal data, you have a mapping for producing those credit card payments, refunding, storing credit card information. So all this is mapped within your application. And it does make sense, but at the same time, it produces some core issues with the implementation, some core security issues in mapping out these entire constraints. But when you have this HATEOAS type of implementation, when you utilize these structures, you have an API constraint that looks like this, where your application on the far left really only has knowledge of that first entry. So it might have knowledge of pay by credit card. And then when you pay by credit card, what happens is the payload that's sent back to you, the response structure, contains a series of links for your next actionable steps. So let's say you're making an auth capture. You're authorizing a payment, then you're capturing it later. So you authorize the payment, and that's the first entry endpoint. Now in the payload that comes back, you have things for, well, actually, let me show you. You have things like this, that you might have a void call that gets sent back as an href. You might have something for making the capture request. You might have something for looking up the payment information. By the standard, you have to send at least one of these links back. One link back. You can send more, you can send a lot. But essentially what you're doing is providing an automation interface for your application, because all you need to know is how to enter that first entry. And then you can build around it. So anything that comes back, you have self-descriptive messaging here. You have a relevance flag in there, your self, your capture, whatever relevance there is in the API that you're working with. You have the HTTP request method that you're going to be utilizing right here for building that request. And based on the API constraints, you have everything that you need. So this is actually a really cool concept, because what you do with this is build this automation infrastructure based on this. Your application changes state as the API changes state. So as the API is updated, you're both future-proofing and providing an automation state. It's really, really interesting stuff when you're working with APIs, because your API essentially will grow with the API. The API changes, and all of a sudden, hey, you still support it. You just have additional features that are available. It's kind of cool. All right, so these are some of the really cool concepts within automation, within REST, that I like working with, some of these open standards. But the vast majority of the APIs that you're going to be working with are not just make a request, get some data back. The vast majority of them have some security mechanism put on them in order to either track the amount of usage for an application, so basically your application state, where the application is communicating directly with the API provider. And that allows them to track basically usage. Or you might have a user involvement step where the user is granting authorization for the application to consume their data at any given time. And that's the standard. And one of the main standards in the industry for that is OAuth 2. Now, I said I was working with OAuth back years ago, but I've integrated probably over 500 direct integrations on top of OAuth 1 and hundreds on top of OAuth 2. And by far and large, there's definitely some differing opinions on OAuth 2 in this state, on security and issues in the constraint of OAuth 2 and how it's actually built. Completely understand that, but speaking as a person who did integrations for OAuth 1 and OAuth 2, OAuth 1 was a pain in the butt. I would have implementations where people would take over a week to implement something if they didn't know what they were doing. OAuth 2, the first time I implemented this, it took me 15 minutes. 15 minutes to do an integration, where OAuth 1 took me a heck of a lot longer. And I'd had problems as I was going through. It's because what they did here with this specification is essentially they made it not only have the security mechanism, but also have the developer aspect where they are making it easier to integrate. And for myself, that's exactly what I want, because I would always presume that every single person implementing this standard should have enough knowledge to implement the security backend to support this and any viable issues that might come up from OAuth 2. And, a lot of this has been vetted out in the industry. But a little background on this. When OAuth 2 as a standard came out, it used to be OAuth 1 was authorization, OpenID was authentication. But when OAuth 2 came out, things got a little confusing because OpenID didn't keep up. OpenID didn't build a spec alongside OAuth. So around draft spec 12 of, I think there were 31 draft specs before the final version of OAuth 2, around 12, Facebook implemented it. And what they did was they utilized it for both authentication and authorization combined for their application infrastructure. It made perfect sense because that's what they needed it for, and they combined the two. They did have some early on issues with it, but those were all implemented or changed based on proprietary implementations. And for the longest time, they didn't update to new draft specifications. But without them implementing it, OAuth 2 wouldn't be as big of a standard as it is today. Thankfully, we have standards to support this now. OpenID Connect, which is one of the standards that we implement at PayPal and have been working with for quite a while, is really nice because it's built off the same easy OAuth 2 standards, but provides user session management. So, for instance, with OAuth 2, implementing it as a user login action, you would have to do token revocation. So if someone wants to prevent the application from gaining access to their data anymore, they would have to actually revoke the token. Usually involves going to the site and doing it manually. But the biggest problem with this is it's time consuming. So the user session management endpoints with OpenID Connect have provided you a mechanism for simply logging out. It has provided you with a whole bunch of different user session issues that allow you to build a user login structure on top of OAuth 2. Now, one of the ways that OAuth 2 is great is for user involvement. So if you need to grant an application permission to access your details or privileged information, you can do so with the standard. Then going further, one of the things that we utilize it for is basically kind of an application-only tracking. So as you're building out an application and you want to track its usage to make sure it's not hitting any upper bounds of usage, then you can do that without the user involvement step. So when we're implementing this within server-side implementations, it's actually pretty straightforward, pretty easy. This is standard in the industry. You're making requests back and forth, you're redirecting people, but it gets a little different in the JavaScript layer because we don't want to expose our private information. We don't want to expose all the things that keeps it secret, that makes this valuable in the first place. Now, thankfully, OAuth 2 has a nice little draft specification in there for doing just this in the JavaScript layer called the user agent flow. The user agent flow allows you to hide that secret key and make these requests through in order to provide a security infrastructure on top of your RESTful API requests. So the way that it's going to work is that you'll first prepare a redirection URI. That's the first step. You need to redirect the user for logging in. And what you're going to do is pass through some information to an authorization endpoint. You're going to pass through your client ID. You'll have those two. Think of it like a username. Response type of token, scopes. Scopes is an optional one if you have dynamic scoping, meaning you basically define what data you want from a user on the fly. You specify it in the scopes there. If you can also have statically scoped items where when you create the application to get your keys in the first place, usually that's on a particular website, then you would define your scopes there. We use kind of a flavor of both. You define a statically scoped environment within your applications when you first create it, and then you can modify that up and down based on the information that you need on the fly. And then a redirection URI, where the user should be forwarded back to once they log in. So then you do a browser redirect. And this entire thing looks like this in JavaScript. It's pretty simple. All you're really doing is building a URI with those constraints that we specified. And what you can do is set up an anchor tag and change it to href to what that URI is. So when they click on that, they go to the authorization capabilities. Then what happens is they log in, they grant permission to the application, and they're forwarded back to the redirection URI. Now, this is where things get a little bit different from standard OAuth implementations. So when you're implementing this specification, this is the point where you would get a code back in the URI that's specified back as a query string parameter, and you would exchange that code for an access token. The access token is your skeleton key for privileged information. But here, this is a little bit different. So you're going to get that redirection URI, but it's going to include a hash mod. The hash mod is going to include your access token, so you avoid that step of exchanging the code for the access token. It's essentially a way of allowing you to do it securely on the client side without exposing your secret. So what's going to happen is in that hash mod in the URI, in the query string parameters, you're going to have an access token, and you might have an expiration time on that access token and a potential refresh token for refreshing the access token once it expires. Then all you really need to do is extract it. And that entire thing looks like this. So the comment at the top, or the gray structure at the top, that's what the URI might look like with the hash mod containing the different access tokens or the different token pieces that you need. So you can just extract that hash. You can do a regex match on it, but sometimes this causes some issues depending on the access token structure that's implemented. So what you can just do is split it apart and pull out the access token structure. So now that you have your access token, you have your skeleton key to begin making privileged API requests for user data or to do user actions. So now to actually make that request, you're going to send this access token in the headers. So you're going to send it through as a verification that, hey, the user has indeed granted me application access. So you're going to have a resource endpoint, think of it like pay credit card, and then you're going to pass through a access token with the token type and pass through your accept data type. And then make a standard HTTPS request depending on the API structure. So that entire thing will look like this in jQuery request. So making a cross-domain request, we're making a request to the resource URI. And before sending, we set the two headers. We set our authorization header with our token type and our access token. And we set our accept header to application JSON, the data that we want back. Then on success, that's when the response structure actually comes back, and the response that's in there is the data payload that we want to consume. So in the JavaScript layer, this is how you do it. This isn't implemented at PayPal yet. And I'm pushing for it because the JavaScript implementation is something that I want to build out. It's something I want to work on. And this type of implementation is actually, once you have the infrastructure or the server-side infrastructure in place, it's actually pretty easy to start building on top of this hash mod because it's just a simple modification in how you do things. So as we're looking at this, there's just a couple of things to keep in mind. Using proper REST standards actually helps you with both future-proofing and automating your application structure. It's It's a really nice way of building lasting applications that you don't have to touch very much. And then those hypermedia constraints within, especially HATEOAS within REST standards, within those hypermedia constraints, are the way to build in automation infrastructure. It's a really nice implementation that if an API supports it, you should be using it, because that's going to future-proof your applications as well. And then finally, using OAuth 2 in the proper way. Not using some backdoor methods that's kind of hacky in the implementation, because the standard supports it. Why not implement to standard if it supports what you need in a very easy way? So the last thing I want to just touch on really quick is, besides the PayPal implementation, we as a company are trying to build these kind of open concepts, and we're doing so within Battle Hack series that we're doing. So essentially, it's a hackathon for good with a good implementation, and if the for good aspect doesn't hit your fancy, then the $100,000 open prize does usually. So we have 10 worldwide locations that we're having this battle hack at, where implementers will have a lot of different API partners that come through and allow you to implement and play with some of these standards, play with the open specifications, play with just open standards. It's really nice. And the winners of each city will be flown out to San Francisco for the World Finals for that $100,000 prize. So that's everything I have to mention, including the call for the hackathon. All my information is there if you want to contact me or take a look at some of these implementations online. I have a lot of OAuth 2 samples on there for doing implementations, and under my GitHub account, and then my Twitter is right there if you need to contact me. And there's the link for this slide share if you want to download it. So thank you very much, everyone, for joining me. It's been a pleasure being here. Do we have any questions? Yes?
Is there still some concern about sending the token? So even though it's hashed there, you're still sending it from the browser? Like I could look at it in Fiddler or something?
Right, so the ideal implementation there is you wouldn't just use the access token, you would use a verification of where the site is sending from. So anyone can define a redirect URI and excuse me, I forgot to repeat the question, which was, is there still a concern in sending that hash mod through? So the access, basically getting the access token from the hash mod and then sending it through. So the security implementations, and this is where it becomes important for your OAuth 2 implementers to know what they're doing and to implement this securely, is that they'll get the access token but also verify where the request is coming from. That request should be verified against the application that was created, so it'll have the same URI, the same domain essentially that it's coming from. It should be restrictive based on subdomains as well, just like you would have with the same origin policy. Any other questions? Oh, yes?
You're sending that, in the spike you would send that secure, right? So you wouldn't really be able to sniff that essentially.
You would send it through an HTTPS request, so that's a main difference between the in the OAuth 2 implementations is all the access is sent back and forth is through these secure connections, and HTTPS as a standard has been around for quite a long time. So it's on a secure connection back and forth. Oh, yes?
So, quick question. With your HATEOAS sort of way of returning back URLs that you then have to go fetch again, how would you optimize this for something, a mobile site that's using this? Because you want to reduce round trips on mobile, so you actually probably don't want to be making all these extra requests when you could all do it at one endpoint.
So the question is, in a mobile website infrastructure, how do you reduce or do this sort of automation in a more efficient way utilizing HATEOAS? So going back to this slide in particular right here, the implementation that's coming back is sending a series of links for next steps. It's not multi-step. So let's say you make a request for paying a credit card. You're going to make that request and it's going to complete. So you're going to make one complete request through. What's returned back is just a potential next steps, which can be to refund. It can be to void or what have you. So they're just next steps that you can take, not that you would have to take. Yes.
On this same slide, there's no mention of content type.
Okay, so this is actually so there's no mention of content type within this slide. So this is actually something that that I should mention about our APIs. Our APIs will always send data back as application JSON. So if the application infrastructure itself through the API will always send back the same uniform data construct, then they will assume that you're always going to be consuming that data and producing that data in the same way. If you have multiple data sets that are being sent through, like if you support XML and JSON, then absolutely you should put the content type right here because that's everything that you're going to need to make the request.
But also, not just whether it's JSON or XML, but what is the payload of JSON that you may be sending? How is that content described?
So that goes back to actually one of the RESTful standards, which is self-descriptive messaging and payload. So a lot of this should be self-described in the payload that comes back, but that's actually one good implementation, good point there, that the actual response structure and the data structure and how it's implemented can absolutely be sent back as the payload because then that helps you build almost a templating infrastructure on top of the APIs. It's a really good point. Yeah. Yes?
In one of your earlier slides, you mentioned the importance of returning proper HTTP status codes.
Yes.
Where I work, a lot of people are against that, saying that would give information to an attacker to help them refine their attack. Do you have any thoughts on that?
The question was about using proper HTTP status codes and whether that opens up a potential attack vector for people. This goes back to your security. So the people implementing this, you should always stick to the standards because it's a standard for a reason. It's self-descriptive, and people will know, and developers will know as they're building off of this that that's how they should consume it, and that's how they should handle the error codes. Now, on the flip side, we have a huge security infrastructure at PayPal in order to support just this, potential attack vectors coming through these standard error codes or standard request types. It comes back to your application infrastructure security. But speaking from the opposite side of not supporting that in our classic APIs, I'd prefer this method and just having a better security on the back end.
That's what I was the first to take back and say, no, let's do it.
Well, developer implementations, you're going to have a much better, much easier way of building for developers this way. All right, looks like we're out of time, so thank you very much, everyone. I'll be at the PayPal booth if you have any other questions.